Hello, everyone. Welcome to the third session after the coffee break here at Shift Room. We're welcoming Reyam Enad from EDF Energy, and she's going to give a talk about fraud models in the energy sector. She's a lead data scientist at EDF, and she's also a founder of a school that offers free courses to empower immigrant women in tech world. So let's welcome Reyam.
Great. Thank you so much for the intro. Good morning, everyone, and thank you for being here today. So I'm going to take you through our recent model in EDF. So this model is about the fraud model and the smart meters. And I'm going to take you through what's the energy theft, what's off-gym and the business use case, what was our model process, and everything regards the starting from the data sources till the result we had and the business feedback regards that. So what's the energy theft? Energy theft, it's about and refers to illegal or unauthorized manipulation or tampering with the smart meters to consume electricity or any other type of energy. On the other hand, smart meters, they are advanced digital devices using to measure and record consumption energy. There are many types of energy theft, meter tampering, and also data manipulation and unauthorized access. All of these, we need to understand them in order to build our machine learning model, because without understanding the actual data and actual problem, we can't build machine learning. So let's move now to the business use case. I'm not sure if anyone here familiar with off-gym and the energy theft. So off-gym started reviewing last year how well the energy suppliers performing with identifying theft in Great Britain. As you see in this slide, energy theft cost consumers around 833 million to 1.38 billion each year. Also, the number of reported cases start increasing every year. At EDF, we have a responsibility under off-gym retail code to identify around 4,000 cases of energy theft each year. And of course, that costs the company right now around £3 million. This is just a small number from the large market, which is around 30,000 energy theft each year. To tackle that, of course, off-gym start reviewing how well we will be performing to detect and identify energy theft. As you can see from this, right now at EDF, we have two models. One, we call it proactive models, this is what I'm going to talk about today. And also, we have something we call reactive models. And with reactive models, it's manual, and it's reported by a third party. However, with the proactive model, which is the current and the newest model we are using to detect around 4,000 confirmed theft at EDF customers. So to start from our model, and then I put this in a really light color because hopefully soon we will ignore this stage by reviewing the result by a third party to confirm theft. Once we have the result from the machine learning, then we will raise cases and send to a site investigation. Again, this is again by a third party. And once we confirm the theft, we use that data to retrain our model. Why we are saying we retrain our model? The only problem we are facing with this project is a tiny data set. I'm going to give a very overview about the whole process, which is starting from the data sources till the output and the action. With the data sources, as I mentioned, we are having a really tiny data set because recently we start recording internally all the cases raised by our employee. And that includes the internal data and also using external data. And then we do the data transformation that include cleaning the data and handling all the issue regards that data, and then doing model training and run. With the model training part, we've been using different type of model in order to find the optimal one among them. And then we do post-processing, because this is a recent problem, and this is something really recent. I think it started last November, last year. So we don't have experience, not only EDF, the whole energy sector. And then after we have result and confirming that fit with all the policies within EDF, we send our investigation for a process. So let's talk about the data, that's the challenging part there. And I believe every data scientist, they will agree with real-time dealing with that, and putting the model into production is not something really cool. However, we use two parts, which is the internal data, using our own data, starting with SAP and Kraken. And if you are from energy sector, I think you should be familiar with Kraken. So Kraken, it's a platform where we use it for our energy customers. And that would provide us with the historical meter performance and also the meter information. And then we use the meter consumption, this is where we receive the data regards how much this customer was using. And also we fit that with some business rules inside EDF. We also using Splunk and smart meter alerts. So as you saw in the first slide, we use third party in different stages. So with the smart meter alert, we receive that through API from a third party about if there is concern about a theft. And then we are using Triopsis, which is the historical lead about the theft. When I say lead, that means it's a confirmed theft. But also that wasn't enough, so I received this project this January, which is around 5 months ago. So at this stage, the project was using only the first three data, and then we added to it these two, and then we start using external data, that's just to help us understanding our customers, because there is lots of regulation regards how we are using the credit data from our customers. So we preferred going with demographic data, this is not for individual, this is for geographic and the postcodes level. So we use Acon, we use Crime, and we use Ocean data, and we use IMD. All of these helped us to prepare and having comprehensive details and knowledge about our customers and the meter consumption. After that, as any data science problem, this is real-time data, so we have an issue about missing values. And when I say missing values, I think I started with the data with 10,000, and I ended up with only 1,000. So with the cleaning data, it was really interesting because we weren't able to delete all the missing values. We had to find ways with handling that missing values. So we use sometimes replacing these values, or sometimes we build a predictive model trying to find these values. So I think I didn't mention that. My team right now, we are focusing with generative AI. So in that step, we use generative AI as well. Of course, when we start with the data, it was all categorical. And with the categorical data, we had to use label encoder. We tried different methods. None of them worked. Label encoder was the best. And then once we have these data, we start adding more numerical features. These numerical features were about how much each customer been using daily, monthly, and yearly. In that stage, when we start talking about the numerical feature, we had a challenge where this customer been only 3 months with us, or this customer been with us for a very long time. That's why we ended up using only the yearly usage of that customer in order to have a representative data for all our customers. With the splitting data, it was really challenging. We couldn't do it randomly, so we tried different methods in order to have representative targets with the training and the testing. I think the main challenge in as I mentioned, this is something new. This is a new problem. We didn't have that much historical data. So you will be surprised about the targets. How much do you think we have confirmed theft among the thousands? Any guess? Only 17. However, after trying to find any other data sources that we could use to help us finding the historical data, we ended up having around 151. And 151, it wasn't really great for any data science problem. However, after we balance our targets, after we have the split between the training and the testing, we try to balance the target by increasing the minority, which is the confirmed theft. Now we have everything ready with the data. We start exploring models. That was the fun part. So with the model, we start with cat boost. With cat boost, it's really perfect for any categorical data because we start only with categorical. So we start with cat boost. However, the classification report and the F1 score in that case was around 51. 51 is not great in data science. However, that was great for EDF because we don't have any automated process to identify theft. And I wasn't happy about the results, even though the stakeholders were happy. But as a data scientist, I know I can't rely on the model. And then we moved to use XGBoost once we start adding more numerical variables there. However, with XGBoost, we didn't see any improvement rather than just increasing to, I think it was 61. However, at the end of the project, we managed to have to try random forest. I'm not a fan of random forest because I know it caused lots of overfitting, but it was really great here. And we had accuracy overall, which is around 89 with the testing data and around 90 with the training data. So the random forests show really great example of how we are going to use proactive methods at EDF in order to automate the process to identify around 4,000 cases each year. So right now this model is into production, and we decided with this one, we are going to use the leads that model provides to retrain the data because, as I mentioned, the current data set is only 1,000 something, which is not great. Even after balancing the data and increasing the training set, it's not great. Also, the perception of the classes, it wasn't really great with the confirmed theft. It's great for the business, but it's not great from a technical perspective because I know the model wasn't struggling, but it wasn't great. However, I did test something really bad, and I wouldn't recommend it. It's just because I wanted to see why the model with the per session is not doing great with the confirmed theft, and it was the data. Because after I was trying to manipulate the data and trying to increase the size of the testing set, the per session is really improved. We have really great accuracy overall. So the business target right now is to increase our accuracy overall to something above 90 with the testing set, and also increasing our per session with the confirmed theft. And we can't reach that stage yet before start providing all the leads we have to the model again. And we are going to do retraining with the model. And after that, hopefully the new leads will try to improve the model. So that basically was everything about this model. Our next step, I think, with the energy theft, I'm planning to start using generative AI. And as you can see, the part code to the right is generated by generative AI. I did write a prompt for the model, and it generated this part code for me. So if you have any more question, or if you have any question, you can ask me now, if we have time. Do we have time? Okay.
Hi.
Hi.
Great. It was great, your presentation. Thank you very much. I have a question. Well, two, if it's possible. What are the meaningful features for your models? And the second, what do you think about applying interpretability in machine learning in the energy sector? Thank you very much.
Can you just repeat the first question? Sorry.
Yes, sorry. what are the meaningful features that you consider in your models?
That's a great question, even though I can't share all the details regarding the data. However, I think the main challenge with this model was we can't use customer data that much. So we had to go with lots of information instead of a direct information with this customer. However, we used the customer, how many times this customer contacted us. If this customer didn't contact us at all, that means there's something wrong, because if this customer been with us for more than 3 years and they haven't been having any issue with the company, that means there's something. So it doesn't mean 100% there's something, but the likelihood of having something is there. Also, the meter reading. So we know, like, we've been in the market for a very long time, and we know, like, the yearly consumption data, it could be, like, if you are a family, it could be that number. If you are a single person, it could be that number. So when we see the number of your consumption data is not really near these numbers, we will raise a flag, there's something wrong there. So they were the main features for us. We did, of course, use many feature importance technique and hyperparameter tuning. I forgot to mention these. However, we don't have enough time for that. That was the main important things. Also, the crime rate, it was really important, because we did find with the crime rate, a high crime rate area has lots of confirmed theft as well. And again, I'm really proud of this model, because we didn't have it before, and we didn't have any automated process. Everything was doing manually. And again, as a data scientist, doing things manually is not really great. What's the other part of the question?
What do you think about... Thank you. Hi. Yeah. What do you think about applying interpretability in machine learning models in the energy sector?
Oh, that's a really good question. I think... Did I mention? I think I mentioned. We are focusing heavily on generative AI right now. That model wasn't something with my team. I did volunteer to do this model because I wanted to show off about we are doing the first automated process. We might start using it soon. I think with the energy sector right now, again, I shouldn't say that, but we are not doing that much with AI. They start involving AI and data science recently within the market, and I think Ofgem will start sending letters about the regulation about using AI and data science. That's why when I had the opportunity to join a company, I joined energy sectors, because there is really a great place to do a lot with data science and AI. Thank you so much. I hope I answered you.
I'm really sorry. I know I see lots of hands, but can you please just take the questions later in the lunch break, because we're having to prepare for the next speaker.
Also, this is my LinkedIn.
Yeah.
If anyone has a question or wants to learn more about machine learning in LinkedIn and energy sector, so you can just contact me. Thank you.
Thank you so much.